Hi, it's Andy from KRÜSS. In this video, we're measuring the contact angle of a porous material, in this case, a powder. We'll use what's called the Washburn method, and in fact, we'll use a special version of the Washburn method called Washburn Direct, which KRÜSS has developed. And this is a simpler and easier to evaluate method than the classical, and it gives more reliable and user-independent results. Now, contact angle analysis is a very useful tool for assessing material wettability or surface activation, but sometimes we come across samples that are particularly tricky to measure. This is most obvious when we're dealing with things like powders, but it can also include all kinds of porous materials like textiles and fibers, membranes, or even rocks or soil samples. Now we're going to take a look at how Tensíío can help us with these tricky samples using this Washburn Direct method. First of all, I should say the Washburn technique lets us measure contact angles even when a liquid is being absorbed into the material. In the case of powders, this can be particularly useful for assessing powder dispersibility. So for example, if you're putting pigments or additives into a solution and you need them to disperse well. In the Washburn method, we use an equation that relates all of the properties of the liquid and solid with each other. For porous materials, the absorption of a liquid into that material is dependent on a few factors. So first of all, for the liquid itself that's being absorbed, we need to consider the density, the surface tension, and the viscosity of that liquid. For the solid that's absorbing the liquid, we need to consider its contact angle, which we give by cosine theta, and something called its capillarity, which relates to the capillary force that's pulling on the liquid. Now, using the Washburn equation, we can relate these properties to effectively the absorption of the liquid, and we write that as change in mass squared over change in time. Now, in a normal measurement, what we want to do is solve this equation to determine cosine theta. Because we will tend to work with a known liquid, we will know a certain number of these parameters already. So the viscosity, the density, and the surface tension of our liquid are known. And our instrument, so Tensíío, will measure the change in mass over the change in time. So we have almost everything we need. The only thing that's missing is this C constant value. And actually, in order to solve this, what we usually do is we will run a Washburn measurement twice. So one time we run it in reverse to determine what C is. And we do this using a liquid of very small surface tension. When the liquid has a very small surface tension, we can be fairly sure that it will wet out to a 0-degree contact angle on our solid. So if the contact angle becomes 0, the cosine theta becomes 1, and now we can solve our equation to find C. Once we've got that value, we can then just repeat the measurement, giving this as an input, and we can calculate what the contact angle is for any liquid we then want to try. Today we have a sample of cellulose powder. Cellulose, in particular microcrystalline cellulose, is a component of many applications. And for example, it's often used in the pharmaceutical industry. Now here it's really important to understand the wettability, because the cellulose is used as a filler in tablets. Though we need to understand how is it going to disperse in the body, and for that we want to measure its wettability. So to do this, we can turn over to Tensíío. First, I'm going to start by opening up Advanced. So when I go into Advanced, first I need to select the measurement method that I'm going to use. In this case, it's absorption. And then I can choose a predefined template and start a new measurement. Once I'm in the measurement, this works just in the same way advanced does for any measurement. So we start at the top left and we work our way down to the bottom right. So that guides us through the measurement process. In this case, I start giving a name to the measurement. As we said before with the equation, for Washburn, I need to know the parameters of my liquid. And actually, Advanced can help me with this. So if I search for the liquid I'm going to be testing, in this case, ethanol, I can select that from the list, and then the relevant properties of this liquid have been brought in automatically for me. So the surface tension, the density, and the viscosity. To the side of this, we also have automatically selected for us that we'll be doing a capillary constant measurement, and we'll be using Washburn Direct. Now we can change these. For instance, I could switch back to the Washburn Classic method, but in this case, we're going to stick with Washburn Direct. From there, we have our automation procedure, which will run Tensíío through the steps it needs to make for the measurement. Down below, we have our live readout from the force sensor. And then here we have all of the controls, the manual controls for Tensíío. Actually, at this point, all I need to do is press the Start Automation button. And I get a small box popping up telling me what steps I need to go through to do a Washburn measurement. So we can start by putting the liquid into the sample vessel, fixing our solid onto the force sensor, and then moving the liquid close to the bottom of the solid. So let's start with that now. So now that we're back at Tensíío, we can start by putting the liquid into a sample vessel. So I've got my ethanol here. And in this case, we actually don't need very much liquid. We just need enough to saturate the powder. So I can just pour some in. And I can place this now on the sample stage of Tensíío. The next thing we need to do is to prepare our solid material, so our crystalline cellulose. For that, we have a special sample preparation set called the Washburn set. And this allows us to pack some powder into a small holder without it falling down into our liquid completely. So first of all, I can take these over to our balance because we need to weigh out a certain amount of the cellulose into this cell. In order to prepare my microcrystalline cellulose for the measurement, I first need to take this metal part of the Washburn set, and I can add from here one of these filter papers into the bottom. Now what this does, it allows the powder to stay inside the Washburn cell without falling out, but still lets my liquid rise up into the powder. Put my glass tube on top, where the powder will be held, and I can screw the cap on. Now I want to put it onto my balance here, which I can then turn the weight. And from here I want to now add in my microcrystalline cellulose, and I want to keep an eye on exactly how much I'm adding. The exact amount that I add is not critical, but I need to be reproducible. So let's add a little bit. Okay, that should do it. Put that onto the balance, and I have 0.2206 grams. Okay, now this will be my first sample for determining the C constant value. So this is going to go into the ethanol measurement. But later, when I want to measure my powder against, for example, water, I want to then prepare my sample as exactly as I can to this one. So that means I'm now going to prepare a second Washburn set. So now we're pretty close to the first sample, so we have 0.22 0.06 grams. So I can take this out, and we've got two very consistent samples prepared. That means we can use one for the C constant and we can use the other for the contact angle, and we know we'll get consistent data. So now that I've got my two samples, I'm almost ready to start measuring. But one thing I need to check first is if my samples are really prepared in the same way. So we're already careful to make sure we have very much the same mass of cellulose inside. But if we look at the side through this window, we can see the level, the height to which the cellulose rises inside is a bit different. And that's because even though I've filled in the same amount of cellulose, the amount of compression of those cellulose particles is a bit different. In order to make these two samples as reproducible as possible, what we can do is apply our own compression. So for that, we have the compression weight set from KRÜSS, where we can take an exact weight and we can compress it for a certain amount of time. So in this case, I have 1 kilogram. All I need to do is take my first sample. I can sit it in here. And then from there, I can now apply the compression from above. And for this, I'll just count to 5, 2, 3, 4, 5. Now I have my compressed weight of cellulose. And I can repeat this for the second sample. One, 2, 3, 4, 5. And now both samples should be as reproducible as possible, both in terms of the compression and the amount of cellulose we have inside. So now we're ready, we can attach them to the force sensor of Tensíío. First of all, I take this here, so I have a small attachment that will let me attach the Washburn cells. I can bring this over to this force sensor. So we just close the door. And now, like always, I need to bring my liquid close to my solid. So I'm just going to rise that up. It should do. And now we can go back into advanced and start the measurement. And all we need to do is to press the OK button on the information box here. Now Tensíío will start the measurement for us. And it will start by running through its automation procedure. So it will open the force sensor and zero it, and then it will start collecting data from the sample. So we'll hear a beep when the liquid has reached the bottom of the sample and it's started to wet onto the powder. You can see the data starting to come in now. And in this first measurement, we're just determining that C constant value. So you can start to see a plot of C constant over time. And in this case, the liquid is working its way up through the powder. So really you can relate time to the height of your liquid on the powder. So now the measurement's finished, we need to fit the data in order to get our C constant value. So we have an initial decrease in the mass caused by the wetting of that liquid into the powder. And then sometime after that, the powder becomes saturated and we don't see any change anymore. This point after the saturation, we don't want to include in our data. We just want the point where the powder is actually being wetted. So we can zoom in here and we can move our fitting bars here just to find the area where we actually have a nice plateau with the wetting. So here. And from this, then we get our C constant value if we scroll further down. Now we have that C constant value of 2.3, we can take that with us to the next measurement and use it as an input for determining the contact angle for this powder. So now, in order to do that second part, I can actually duplicate this first measurement. Now I have an exact copy of the first measurement, but I want to make some small changes. So first of all, I'll change the name. This time I'm not going to measure with ethanol. That was just to determine the C constant. This time I want to measure with water. So I can look up water in the database. And again, the viscosity and density and surface tension information for water will now be filled in for me automatically. I can now change the type of measurement. So before I did capillary constant, now I can do contact angle. And I get an extra box where I have to tell it what the capillary constant was from the last measurement. So it was 2.3. And again, now I can go and press the Start Automation button to start again. And it will give me my small information box, tell me what I need to do. So we can go back over to Tensíío and put in the second sample. So the first thing we have to do is to take out the sample from the last measurement. So I can move down with the sample stage. I can take out the old powder measurement, it's finished, and I can take away the ethanol. Now I can place in my next sample, my fresh sample. And then we just need to put in our liquid. So I've got here another sample vessel and some distilled water. Like before, we should move the liquid close to the bottom of the sample. So we'll just move up. Now again, we go back to advanced and start the measurement. And just like before, all we have to do is press the OK button on the information box, and advanced will start the measurement for us. Like before, Tensíío will run through its automatic procedure, first opening the interlock on the force sensor, and then moving the liquid slowly towards the bottom of the powder. Once the liquid has touched the bottom of the powder, it will start to wet and we'll hear a beep, and then we'll start to collect some data. So we can already see the data coming in live, plotted as cosine theta versus time. And that tells us now that the liquid has started to absorb into the powder. And over time, the liquid is going to rise up the height. So we can actually think of this graph of cosine theta versus time as the contact angle as it changes up the column of the powder. Okay, so now the measurement's finished and we have our data. Again, like before, we can filter the range across which we're actually trying to determine our contact angle. And you can see, just like before, we have an initial spike, so that's caused to the initial wetting of the bottom of the sample holder of this Washburn cell, where we have a sudden jump up in mass. That mass will then come down as the wetting levels off, and we have a constant wetting, so a constant contact angle as the water is wetting through the cellulose. And then towards the end, as the water has now saturated the cellulose, the mass will drop off again. And we can see that in the curve where our value drops down to null. So again, like before, I can filter to just on this plateau where I have a constant wetting, or in other words, a constant contact angle. And now this is what we see from Washburn Direct. So we have this plot of cosine theta versus time. If we were to do this with classical Washburn, it would rather look like this, mass squared over time. So this actually makes it easier to see what's going on in a way. So we have that initial wetting of the bottom of the sample holder, which we have here, this steep jump. Then we have a roughly linear increase in the mass squared over time. And then as the powder saturates, it goes flat again. So we're not collecting up any more mass. Classical Washburn should be made by analyzing this linear portion of the graph, so this straight line in the middle. And we want to take the gradient of that line to calculate contact angle for the whole data set. What Washburn Direct does it allows you to get a contact angle for every single point that was collected, not just getting an average contact angle across the sample. This is important if you want to check for inhomogeneities in your sample, if you have different contact angles, maybe you have a mixed powder. And also, what Washburn Direct lets you do is it's much easier to spot when something's not wetting properly. So if you have something that's not packed correctly or you have something strange with your powder, with classical Washburn, you can always see this shape, this roughly linear shape. And it's quite difficult to decide when that shape is fitting with the theory and when not. With Washburn Direct, you can see that quite easily, right? We're expecting to see a plateau in the contact angle. So we have a constant contact angle over time. If we don't see that, if we just see lots of noise or it decays directly to zero, then we straight away see that this was a bad measurement and we need to reproduce it maybe. So now if we go down to the bottom of the software, we can see in our summary the result which tells us the average contact angle for this data set across the range that we fitted in our graph. So in this case, we have 63.7 degrees with a standard deviation of plus minus 3.8. Now that we have the contact angle data, we can consider what this means for the wettability of the cellulose, particularly in this case with water. If we wanted to go even further, we could extend this analysis by measuring with more liquids. This then allows us to calculate things like the surface free energy of the powder, the polar to disperse ratio of the surface, and even things like the work of adhesion or the free energy of dispersion, which tells us about how easily these particles will disperse in solution. So this was our video for the Washburn method with Tensíío. Thanks for watching. I'll see you next time.